So today we'll discuss greatest integer function. Now greatest integer function, as the name itself suggests, it has something to do with integers, and we human, we have more affinity towards integer than any other number, say rational, irrational, complex or hypercomplex numbers. Now I fail to understand why so many students and some teachers, they find it little different, little difficult, and they find it tough to solve problems when it concerns greatest integer function. So we'll explore what greatest integer function is, and we'll explore its property so that we'll be able to solve the problems related to greatest integer function. Now a greatest integer function fx, it looks like fx equals the square bracket x, and in any standard text they'll mention it specifically. These boxes, they're going to represent greatest integer function. Now what does this function do? Suppose I have any number x, I can express any number x as sum of its integral part plus its fractional part. So this n is its integral part and this f is its fractional part. So in a way, this n, it should be an integer, so n belongs to z, and this f being a fraction, the value of f should lie between 0 and 1. And when I can express this number x as n plus f, and if I take greatest integer function of x, then greatest integer function of x will give me its integral part, and which is n in this case. Say for example, suppose I have to find greatest integer function of 1.2. Now I know that I can write 1.2 as 1 plus 0.2. So its integral part is 1. So the value of 1.2 is simply 1. Now let us take another example, say it is 5.79. Now I can write 5.79 as 5 plus 0.79. So its integral part is 5 and its decimal part is 0.79. So the value of 5.79 greatest integer function is simply 5. Now what if I have negative numbers? Say for example, suppose I have to find greatest integer function of minus 1.2. Now this minus 1.2, I can write it as minus 1 minus 0.2. But here I have a problem. And what is the problem? Problem is this fractional part f, it should be a positive number lying between 0 and 1. And here I am getting a fraction which is negative. So rather than expressing it in this way, we actually express minus 1.2 as minus 2 plus 0.8, and that is the correct way of expressing minus 1.2. So its integral part is minus 2 and its fractional part is 0.8. So greatest integer function of minus 1.2 is simply minus 2. Now what about greatest integer function of minus 5.79? So rather than writing it as minus 5 minus 0.79, I'll write it as minus 6 and plus 0.21. So in this case, its greatest integer function will be minus 6. So the greatest integer value of 5.79 is minus 6. What about this? Minus 5. Minus pi is minus 3.14. Now because it is minus 3, then its greatest integer function will be simply minus 4. So essentially, greatest integer function is nothing, but it's a function which is going to give you integral part of any given number or any given real number x. So say if the number is positive and with a fraction 1.2, it'll be 1, 5.79, it's 5, pi 3.14, it's 3, and for the negative number minus 1.2, then minus 2, minus 5.79, then minus 6, minus 3.14, then minus 4. And in case if it is an integer, then the greatest integer function is that number itself. So if it is 2, then it will be 2, and if it is minus 2, then it will be minus 2. Now say for example, I need to find the value of greatest integer function of e minus pi. Now I know that the value of e is 2.71 something, and minus, and this is minus 3.14. Now it's a positive number. So what is greatest integer function of 2.71? So it is 2 plus 0.71. So its integral part is simply 2. And then minus Now minus 3.14. Minus 3.14 is minus 4 plus positive fraction. So in this case, its greatest integer function will be minus 4. So 2 minus of minus 4 is 6. So answer to this question is simply 6. So the question is, there is a function fx which is defined as cos greatest integer function of pi square by 2 into x plus sine greatest integer function of minus pi square by 2x, where this box represents greatest integer function, and I need to find which of the following options is or are correct. So it's a multiple choice, multiple option correct question. So more than one option may be correct. So what I know is the value of pi is 3.14. Now pi square is 9 point something. Now pi square by 2 will be 4 point something. So if I'll take greatest integer function of pi square by 2, so I know it is 4 plus some fraction part, so its greatest integer function will be 4. Now what about minus pi square upon 2? Now in this case, it will be minus 4 point something. So minus 4 point something is actually minus 5 plus positive decimal part. So in this case, its greatest integer function will be simply minus 5. So if I put the value of these two greatest integer function, I can write this function fx as cos, and pi square by 2 is 4. So cos 4x, and plus sine, and this is minus 5x. Now sine minus theta is minus sine theta. So I'll actually write it as fx is cos 4x minus sine 5x. Now look at option number 1. Option number 1 says find the value of f0. So if I'll put x as 0, I can write it as cos 4 into 0 minus sine 5 into 0. Now cos 0 is 1 and sine 0 is 0. So it is 1. So the value of f0 should be 1. So which is correct. So option A is correct. What about option B? F pi by 3. So I'll put the value of x as pi by 3. I can write it as cos 4 pi by 3 minus sine 5 pi by 3. So now I know cos 4 pi by 3 is nothing but cos pi plus pi by 3, and sine 5 pi by 3 is 2 pi minus pi by 3. Now cos pi plus theta is minus cos theta. So this is minus cos pi by 3, and sine 2 pi minus theta minus sine theta. So minus and minus will be plus. So there will be plus sine pi by 3. So cos 60 minus 1 by 2, and this is under root 3 by 2. So I can write as root 3 minus 1 by 2. So if I'll rationalize, root 3 plus 1, root 3 plus 1. So here 2 and 2 will cancel. So this value will be equals to 1 upon under root 3 plus 1. So that is option number B is also correct. What about option number C? The value of f pi by 2. Now if I put x as pi by 2, I can write as cos 4 pi by 2 minus sine 5 pi by 2. Now cos 4 pi by 2 is simply cos 2 pi, and sine 5 pi by 2 is simply sine 2 pi plus pi by 2. Now cos 2 pi is 1 and sine 2 pi plus theta is sine theta. So sine 90 is 1. So 1 minus 1 is 0. So that is option number C is also correct. Now we'll come to option number D. So I'll simply put the value of x as pi. So if I'll put the value of x as pi, I can write it as cos 4 pi minus sine 5 pi. So the value of cos 4 pi is a multiple of 2 pi, which is 1, and sine n pi is 0. So this value should be 1, but it is given that f pi is 0. So that is option number D is incorrect. So A, B and C, they are correct options. The option number D is incorrect. So this is how we write the greatest linear function of the given numbers. So now we know greatest linear function is nothing but integral value of any given real number x. Now any greatest linear function is nothing but a constant function between the two given integers. So if I look at the properties of greatest linear function, so the first property itself is, suppose there is a number x and that number lies between n and n plus 1, where n is an integer, then simply greatest linear function of x will be n. Now say for example, suppose I say the value of x lies between 0 and 1. So when the value of x lies between 0 and 1, so what I know is the value of greatest linear function x, so any number between 0 and 1, say for example 0.2 or 0.7. So it is 0 plus 0.2, 0 plus 0.7. So obviously it's integral part is 0. So for any x that lies between 0 and 1, including 0 and excluding 1, then its greatest integral function of x will be 0. What if I say x lies between 1 and 2, say 1.2, 1.7, 1.93. So greatest integral function of 1.2 will be 1. 1.7, it is 1. 1.93, it is 1. So for all the numbers that lie between 1 and 2, its greatest integral function x will simply be 1. In the same way, I can write any number that lies between 2 and 3. So that is 2.2 or 2.7, 2.93. So it can be expressed as 2 plus 0.2, 2 plus 0.7, 2 plus 0.93. So in this case, its greatest integral function of x will be 2, and it will continue. If I look at the negative numbers also, say for example, if I say x lies between -1 and 0, say for example, suppose I say greatest integral function of -0.2. Now I know that minus 0.2, I can write it as -1 plus 0.8. So this value is equal to -1. In the same way, greatest integral function of -0.7. So this is -1 plus 0.3. Remember, fractional part has to be positive. So in this case also, its greatest integral function will be -1. So any number x that lies between -1 and 0, its greatest integral function of x will be -1. So that is, if I have any number x that lies between two integers, two consecutive integers, n and n plus 1, so it will always go to its left value. So it will always go to n. So greatest integral function of x in this case will be n. So as is the case when x lies between 0 and 1, so it is 0. 1 and 2, it is 1. Between -1 and 0, then it is -1. Now, if I need to draw the graph of this function, then I can simply draw the graph as, so that's your x-axis and y-axis. I'll mark the points 1, 2, 3, 4, -1, -2, -3, -4, 1, 2, 3, 4, -1, -2, -3, -4. Now, when x lies between 0 and 1, it is 0. So between 0 and 1, this value will always be 0. And it is not included at 1 because greatest integral function of 1 is not 0. Greatest integral function of 1 is 1. So that is the reason I have included 1 here between 1 and 2, not between 0 and 1. In the same way, when x lies between 1 and 2, its greatest integral function is 1. So between 1 and 2, the value of x is simply 1. Between 2 and 3, it is 2. Between 3 and 4, it is 4. Between -1 and 0, -1, -2, -3, and -4. So that is the graph of greatest integral function of x. So this is y equals step x or greatest integral function of x, and it looks like a series of steps, and that is the reason it is also called as a step function. So any greatest integral function is nothing but it's a constant value between any two successive integer, and that is the reason I say it is a very simple function, because it is always easy to deal with a constant rather than any varying function. So greatest integral function between any two given integers is nothing but a constant value. So we just have to keep this in mind. Now the second property of greatest integral function is greatest integral function of x is an integer. So it can only take integral values. It cannot take random fractional values. So whenever you see greatest integral function, think of it as some integer. Say for example, suppose we have a question where it says, suppose function fx is sine greatest integral function of 2 to the power x plus x square plus 4 minus sine x into pi upon 1 plus x square. Now it says that you have to find the range of this function. Now what I see is, I see a complicated expression, but I do see a greatest integral function. Now what I know is greatest integral function is actually nothing but an integer. So here in this case, 2 to the power x plus x square plus 4 minus sine x, it is nothing but any integer, say n. So I can actually write as sine n pi upon 1 plus x square, where n belongs to z, and I know that at n pi the value of sine x is simply 0. So this function is actually nothing but a constant function in which is fx is equal to 0. So this function fx can take only one value for all the values of x, and which is 0. So that's the reason the range of this function is simply 0. So we may get a question where they have used greatest near function just to represent an integer in a complicated way. So in this case, this answer is simply y is equal to 0. Now let us take another question. Say for example, I need to solve this question, which is 2 times greater function of x square minus 5 times greater function of x plus 2 equals to 0, and it is solved for x. Now what I'll do is, I know it's a quadratic equation in greatest integral function of x, so I'll let greater function of x is y. I can write it as 2y square minus 5y plus 2 equals to 0. So I'll write it as 2y minus 1, y minus 2 equals to 0. So that is either the value of y is 1 by 2 or the value of y is 2. So now I put the value of y is greatest integral function of x. So either greatest integral function of x is 1 by 2 or greatest integral function of x is simply 2. Now greatest integral function of x equals 1 by 2. Now 1 by 2, it's a fractional value. It's not an integral value. Greatest integral function of x can only take integral values, not fractional values. So in this case, there will be no solution to this equation. Now, what about greatest integral function of x is equal to 2? So when is the greatest integral function of any number 2? So 2.01, 2, 2.1, 2, 2.2, 2. So what we know is, when x lies between 2 and 3, then in that case, the value of greatest integral function of x is 2. So in this case, answer to this question is simply the value of x should lie between 2 and 3, where 2 is included and 3 is not included. So now the question is, find the value of greatest integral function of 1 by 4 plus greater function of 1 by 4 plus 1 by 200, 1 by 4 plus 2 by 200, 1 by 4 3 by 200, and this series goes all the way up to 1 by 4 plus 199 by 200. So what I'll do is, I can write that as summation r varies from 0 to 199, and this is 1 by 4 plus r by 200. Now what I know is, any greatest integral function, it is nothing but an integral value. So when 1 by 4 plus r by 200 is less than 1 and greater than 0, in that case, the value of 1 by 4 plus r by 200 greatest integral function, this value will be 0. And when the value of 1 by 4 plus r by 200 lies between 1 and 2, then in that case, its greatest integral function of x, its greatest integral function will be simply 1. So now I need to know when this value is less than 1. So this value will be less than 1 when r by 200 is less than 1 minus 1 by 4, which is r by 200 is less than 3 by 4. That is when r is less than 3 by 4 into 200. So which is r is less than 150. So whenever the value of r is less than 150, in that case, the value of this greatest integral function of x will always be 0. Now, between these two, so if I take 1 by 4, on the left and right, I can write 3 by 4 is less than r by 200 is less than, now 2 minus 1 by 4, so it will be 7 by 4. If I multiply it with 200, so that's 150, and then that is 350. But we do have the value of r where it goes from 150 to 199. So that is when the value of r lies between 150 and 199, in that case, its greatest integral function will be simply 1. So what I'll do is, I'll express it in two parts. So I'll write it as summation r varies from 0 to 149, greatest integral function of 1 by 4 plus r by 200, and plus summation r varies from 150 to 199, and this is 1 by 4 plus r by 100. Now in this case, in each of this case, the value of r when lies between 0 and 150, in that case its greatest linear function is nothing but 0. And in this case, when r lies between 150 and 199, so it is simply 1. So summation 1 when it starts from 150 to 199 is simply 50. So answer to this question is 50. So let us take up an example. So it's a trigonometric equation and it says greatest interior function of 10 cube x plus 10x minus 2 is equal to 0, and we need to solve for x. Now how do I solve this question when it has a greatest interior function on 10 cube x, and I know that range of 10 cube is from minus infinite to plus infinite. So I cannot actually break it up in separate integral values and then solve the equation, because then it will be simply too many cases. But what I do know is I can simply write 10x as 2 minus greatest interior function of 10 cube x. Now 2 is an integer. Greatest interior function, it is nothing but an integer. Now when I have two expressions on the right hand side, both of them they are integer, then from there I can say this 10x is actually nothing but an integer. So in this question, this 10x is an integer, and when x is an integer, I know that greatest interior function of x is simply x. So if 10x is an integer, 10 cube x is also an integer. So in that case, the greatest interior function of 10 cube x will be simply 10 cube x. So I can write it as, so I can write this equation as simply 10 cube x plus 10x minus 2 equals to 0, which is nothing but a cubic equation in 10x. So what I'll do is I'll let 10x is y, so I'll write it as y cube plus y minus 2 equals to 0. Now one of the root of this equation is 1. So 1 plus 1 minus 2 equals to 0. So that is the value of y is 1. So if I use synthetic division, I can write that this is 1 and coefficients are 1, 0, 1 and minus 2. So this is 0, this is 1. So it is 1, 1, then again 1, 2, and then 2. So then it will be 0. So I can write it as y minus 1, y square plus y plus 2 equals to 0. So in this case, it will have imaginary root. So the only real root possible in this case is y equals to 1. That is, the value of 10x should be 1. And mind you, this value has to be an integral value. So in this case, it actually is an integral value. So 10x equals 1, which is 10 pi by 4. So general solution of 10x equals 10 alpha. So it is x equals n pi plus alpha. So solution to this equation is x equals n pi plus pi by 4, where n is an integer. So this is how we are going to solve these questions. Third property of greatest interior function is greatest interior function of x plus n is equal to greatest interior function of x plus n when n is an integer. So it is only true when n is an integer. Generally, if we have greater function of x plus y, it is generally not equal to greater function of x plus greatest interior function of y. It is only true when the other expression is an integer. So in that case, I can write it as greater function of x plus n. Say for example, if I have greater function of x plus 3, I can simply write it as greater function of x plus 3. Or maybe I have this x minus 2. I can write it as greater function of x minus 2. Now what about this one? 2 minus x. Now again this 2, it's an integer. So I can write it as 2 and then plus greater function of minus x. I cannot write it as 2 minus greater function of x, because in greatest interior function, we do not have this property that a into x is equal to a into greater function of x. So this is generally not true. So 2 minus greater function of x will be 2 plus greatest interior function of minus x. So this is how we can use property where greatest interior function of x plus n is greatest interior function of x plus n when n is an integer. Say for example, Suppose I am given this integral, which is integral from 0 to 2, greatest integral function of x plus greatest integral function of x plus greatest integral function of x into dx. Now what I'll do is, I'll take this expression, I'll take this function. So this function fx is greatest integral function of x plus greatest integral function of x plus greatest integral function of x. Now for this greatest integral part, this is your x and this is simply n. Now what does the property say? Property says greatest integral function of x plus n is simply greatest integral function of x plus n. So I can actually write it as x plus, which is greatest integral function of x, and then what is n? N here is greatest integral function of x. So I can write it as x plus 2 times greatest integral function of x. Now this again is x and this again is an integer. 2 into greatest integer is an integer, right? So this again is x plus n, and x plus n is again greatest integral function of x plus n. So this expression, it simplifies to 3 into greatest integer function of x. So if I have to solve this integral, all I need to do is, I'll just need to write it as 0 to 2 and then 3 times greatest integral function of x into dx. So I'll take this 3 out. Now what I do know is, between any two successive integer, greatest integral function is nothing but a constant value, right? So what I do is, I'll split this integral in 2 parts, from 0 to 1, greatest integral function of x dx, and then plus from 1 to 2, greatest integral function of x into dx. Now between 0 and 1, the value of greatest integral function of x is 0, and between 1 and 2, greatest integral function of x is simply 1. So I can simply write it as 3, and this integral is 0, and this is integral of 1 by 2 into 1 into dx, which is x. So answer to this question is simply 3. So that is the answer to this question. So the question is, we are given two simultaneous equations, which is y equals 2 times greatest integral function of x plus 3 and y equals 3 times greatest integral function of x minus 2. We need to find greatest integral function of x plus y. So what I know is, for the second expression, I can write greatest integral function of x plus n as y equals 3 into, now this is greatest integral function of x and then plus n. So if I multiply this 3, I can write as y equals 3 times greatest integral function of x minus 6. Now we have two linear equations. Now these are linear equations not in x and y, but they are linear equation in greatest integral function of x and y. So I'll use variable elimination. So I'll eliminate y. So if I'll equate these two, I can write it as 2 times greatest integral function of x plus 3 is equal to 3 times greatest integral function of x minus 6. So if I take it on the right hand side, I can write greatest integral function of x is equal to 9. Now we know that when x lies between n and n plus 1, greatest integral function of x is simply n, or vice versa. So when greater function of x is n, then the value of x lies between n and n plus 1. So simply I can say the value of x lies between 9 and 10. Now, if I put the value of x in the first equation, greater function of x in first equation, I can get the value of y. So value of y will be 2 into 9 plus 3. 18 plus 3 is 21. So in this case, greatest integral function of x plus y is, now y being an integer, I can simply write it as greatest integral function of x plus y. So greater function of x, the value is 9 and the value of y is 21. So 9 plus 21 is 30. So answer to this question is simply 30. Now the fourth property of greatest integral function is greatest integral function of x plus greatest integral function of minus x, and this value is 0 when x is an integer, and this value is minus 1 when x is not an integer. Now say for example, for the first case, when suppose x is an integer, suppose x is n. So greatest integral function of x will simply be greatest integral function of n, and it being an integer, so this value will be simply equal to n. Then the same way, greatest function of minus x, so it will be greatest integral function of minus n, and it will simply be minus n. So if I'll add them up, so I can write as greatest new function of x plus greater function of minus x. So there will be n minus n. In this case, the value will be 0. Now in the second case, when x is not an integer, suppose x lies between n and n plus 1. Now in this case, greatest function of x will be simply n. Now if I multiply with minus, then it will be minus n, and then sign will reverse. Is greater than minus x is greater than minus n plus 1. So in that case, the greatest integer function of minus x will be simply minus n plus 1. Now if I'll add them up, I can write it as greatest integer function of x plus greatest integer function of minus x. So there will be n minus 1. So this result will be simply minus 1. So basically x plus greatest function of minus x is 0 when x is an integer, and this is minus 1 when x is not an integer. Now the question is, a function fx is defined as greatest integer function of x plus 1 by 2 where x is not an integer, and this box represents greatest integer function, and we need to find the value of f minus x. So I'll find f minus x. Now I can write f minus x as greatest integer function of minus x plus 1 by 2. Now when it is given that x is not an integer, in that case, what I know is greatest integer function of x plus greatest integer function of minus x is equal to minus 1. So I can write greatest integer function of minus x as minus 1 minus greatest integer function of x. So if I'll put it here, I can write it as f minus x as minus 1 minus greatest integer function of x plus 1 by 2. So it is minus 1 by 2 minus greater function of x. So if I take minus common, I can write it as greatest integer function of x plus 1 by 2, so which is nothing but fx. F minus x is simply minus fx. So answer to this question is simply minus fx.
Now we'll move to next set of transformations, and next set of transformation involves greatest integer function. So from the graph of y equals fx, I have to draw the graph of y equals f greatest integer function of x. Now what we already know is if x lies between n and n plus 1, greatest integer function of x will be n. So what I'll do is I'll draw the graph of fx and then I'll draw vertical lines at integral points on x. So say for example, suppose I have to draw the graph of y equals greatest integer function of x whole square, and suppose I have to draw this graph between minus 2 and plus 2. So my basic graph will be y equals to x square, and I'll draw this graph. So in order to draw the graph of y equals greatest integer function of x square, my first step is draw the graph of fx and then draw vertical lines at integral points on x-axis. So I'll draw vertical lines at minus 2, minus 1, 0, 1 and 2. Now second step is mark points of intersection and find corresponding values of x and y. So I'll mark these point of intersections. Now what's the value at minus 2? So when x is minus 2, this value is 4, this value is 1 and this is 0. Third step is for graph between n and n plus 1, draw a horizontal line. So for graph between minus 2 and minus 1, I'll draw a horizontal line. For minus 1 and 0, I'll draw a horizontal line. For 0 and 1, I'll draw a horizontal line. Again here. So the graph which I have drawn in red represents the graph of greatest integer function of x square. I'll take up another example. Say for example, I have to draw the graph of y equals under root of greatest integer function of x when x lies between 0 and 4. So my basic graph will be y equals under root of x. So that's the graph of under root of x. Now I'll draw vertical lines at integral points. So I'll draw this line at 0. I'll draw this line at 1, at 3 and at 4. And I'll mark these point of intersections. Now when x is 1, y is 1. When x is 2, y is root 2. When x is 3, y is root 3. And when x is 4, y is 2. So now, in between n and n plus 1, draw a horizontal line. So I'll draw a horizontal line. The graph which I have drawn in black represents graph of square root of greatest integer function of x. Now we'll move to the 13th transformation, and this one is very important, and this is y equals greatest integer function of fx. So now here I'm taking greatest integer function around the whole function. So this is one of the very important transformations. Now I'll take up an example. Say for example, I have to draw the graph of y equals greatest integer function of x square when x lies between 0 and 2. Now what are the steps involved for this graph? My basic graph is y equals x square. So I'll draw the graph of y equals x square. So that's the graph of y is equal to x square between 0 to 2. So first step is draw y equals to fx and draw dotted horizontal lines at integral points on y-axis. So on y-axis the integral points are 4, 3, 2 and 1. Now second step is mark points of intersection and find corresponding values of x. So I'll mark points of intersection. I'll find corresponding values of x. So if I'll put y as 2, I'll get x as root 2. So this value is under root 2. And the same way if I put y as 3, I'll get this as root 3. Now what's the next step? Now for the graph between y equals n and y equals to n plus 1, draw a horizontal line at y equals to n for successive values of x. So between 0 and 1, draw a horizontal line at 0. Between 1 and root 2, when y is between 1 and 2, so that is when x is between 1 and root 2, draw a horizontal line at 1. In the same way at root 3, in the same way between root 3 and 2. So the graph in black is actually your graph of greatest integer function of x square. So fourth step is erase graph of y equals to fx and dotted line. So that means I'll redraw this graph. That's the graph of y equals greatest integer function of x square. I'll take up another one. Suppose I have to find this integral, which is 0 to infinite greatest integer function of 2 upon e to the power x. So what I'll do is I'll draw the graph of y equals greatest integer function of 2 upon e to the power x. Now here my basic graph is y equals 2 upon e to the power x, or I can write y equals 2 into e to the power minus x. So I'll draw this graph. Now I need to take the transformation of greatest integer function of x. So draw horizontal lines at integral points of y. So I'll draw horizontal line at minus 2 and I'll draw horizontal line at 1. I'll mark these point of intersections and I'll find the corresponding value of x. So if I'll put y as 1, value of x will be ln 2. Now between y equals 1 and 2, draw a horizontal line at y equals to 1. Between 0 and 1, draw a horizontal line at 0. So the graph in red represents the graph of greatest integer function of 2 upon e to the power x. Now if I have to find this definite integral, I'll just need to find this area. And this area is actually a rectangle. Answer to this question is ln 2. I'll take up another question, and that question is y equals greatest integer function of 2 sin x. Now here again my basic function is y equals 2 sin x, and I'll draw this graph between x equals to 0 and x equals 2 pi. So I'll draw the graph of 2 sin x. And I'll draw horizontal lines at integral values of y. I'll mark their point of intersection. So this is 0, pi and 2 pi. Now this is pi by 2 and this is 3 pi by 2. Now when I'll put y as 1, I'll get sin x equals 1 by 2, which is pi by 6. From symmetry I can say this is pi minus pi by 6, it will be 5 pi by 6. And this one will be pi plus pi by 6, so there will be 7 pi by 6, and here it will be 2 pi minus pi by 6, so there will be 11 pi by 6. Now I'll draw horizontal lines. So between 0 and pi by 6 it will be 0, then so the graph in black is actually the graph of greatest integer function of 2 sin x. And now in this graph, they may ask you to find continuity, differentiability, or area, or the value of definite integral. We can find it simply using the graph.
Now the fifth property of greatest integer function is the value of greatest integer function of x will lie between x minus 1 and x. We know that any x is greatest integer function of x plus f, and this f, it belongs to 0 and 1. So it is greatest linear function of x plus some value. So its maximum value will be simply x, and x minus 1 will always be less than greatest linear function value. Now we use this property while solving limits. Say for example, we have this question which is limit n tends to infinite, greatest linear function of 1 square x plus 2 square x up to n square x divided by n cube. So what we know is, because this n tends to infinite, it is infinity upon infinity form. Now any greatest linear function of x, it will lie between x minus 1 and x. So I can write 1 square x will lie between 1 square x minus 1 and 1 square x. In the same way, 2 square x will lie between 2 square x and 2 square x minus 1. 3 square x will lie between 3 square x and 3 square x minus 1, and this series will continue up to n, that is n square x minus 1, get a function of n square x, and this is n square x. If I add them all up, I can write it as 1 square plus 2 square, it goes up to n square into x, and then minus 1 minus 1 minus 1 n times, so there will be minus n, and this is less than greatest linear function of 1 square x, greater function of 2 square x, greater function of n square x, and it will be less than or equal to 1 square plus 2 square up to n square into x. Now for this limit, I'll need to divide it with n cube. So I'll divide each of the three expressions with n cube. And I'll also take this limit n tends to infinite for all the three expressions. Limit n tends to infinite. Here also I'll take limit n tends to infinite. And here also I'll take limit n tends to infinite. Now 1 square, 2 square up to n square. This is nothing but limit n tends to infinite. This is n plus 1 to n plus 1 by 6 into x, and then minus n whole divided by n cube. Here it will be simply, so I'm not going to solve this limit. So I'll simply write it as 1 square x up to n square x upon n cube, and this is again n plus 1 to n plus 1 by 6n cube into x, and this is limit n tends to infinite. Now it's an infinite limit. Now in infinite limit, if the degree of numerator and denominator is same, so the degree of numerator is 3 and the degree of denominator is also 3. So answer to this limit simply will be the leading coefficient of n cube in the numerator, which is 2 by 6 x, and leading coefficient of n cube in the denominator, which is 1. And in this case also, it is a polynomial of degree 3 in the numerator, and here also degree in the denominator of n is 3. So again in this case, it will be 2 by 6, which is 1 by 3 x. Both these limits on the left hand side and also on the right hand side, the value of both the limits is 1 by 3 x. Sandwich theorem or squeeze play theorem says, if we have a function fx which lies between f1x and f2x, and if I take limit x tends to a, f1x if the value of this limit is L and the value of second limit is also L, then in that case, the limit of this function x tends to a fx will also be L. So from sandwich theorem, we can say that the value of this limit will also be 1 by 3x. We use this property while solving the problems in limits. Now the sixth property in greatest linear function again has something to do with limits. So suppose I have any number a, which is an integer, and h is a very small positive number which is nearly 0, then greatest linear function of a minus h will be a minus 1, and greatest linear function of a plus h will be simply a. Now say for example, if I say 2 minus h, Now h is very small positive number, so minus 0.0001. So that will make it 1.99999 something, and greatest integer function of 1.99 something will be simply 1. But if I take greatest integer function of 2 plus h, so there will be 2 plus 0.00000001. So in that case, this value will be 2 point something. So in this case, the value of greatest integer function of 2 plus h will simply be 2. So if it is a minus h, it will be a minus 1. And if it is a plus h, then it will be simply a, when h is a very small positive number and a is an integer. Now say for example, a question is given as limit x tends to 1, 2 minus x plus a into greatest integer function of x minus 1 plus b into greatest integer function of 1 plus x. It says this limit exists. Then find the value of a and b. Now, what we do know is the greatest integer function, it is discontinuous at integral points. So it simply means I need to take both left hand limit as well as right hand limit. So if I write its left hand limit, I can write left hand limit as limit x tends to 1 negative 2 minus x plus a into greatest integer function of x minus 1 plus b into greatest integer function of 1 plus x. Now it is 1 minus, so we are approaching 1 from the left hand side. So I'll do the substitution. I'll let x as 1 minus h. Now when x is 1, h is 0. So I can write it as limit h tends to 0 positive. So this is 2 minus 1 minus h plus a into greatest integer function of 1 minus h minus 1 plus b into 1 plus 1 minus of h. So I can write it as limit h tends to 0 positive. So this is 1 plus h and then a greatest integer function of minus h plus b greatest integer function of 2 minus h. So now this is 1 plus, now h is nearly 0, so this is 0, a into, now what about greatest integer function of minus h? Now greater function of minus h is actually 0 minus h. So when it is a minus h, it is a minus 1. So the value of this greatest integer function of minus h will be simply minus 1 and b into 2 minus h. So 2 minus something will be 1. So left hand limit will simply be 1 minus a plus b. Now I'll take right hand limit. Now for right hand limit, I'll write limit x tends to 1 positive, and this is 2 minus x plus a into x minus 1 plus b into 1 plus x. Now I'll again do the substitution. I'll let x as 1 plus h. So I'll write it as limit h tends to 0 positive 2 1 plus h plus a 1 plus h minus 1 b 1 plus h plus 1. So here will be limit h tends to 0 positive. So this is 1 minus h. Now 1 and 1 will cancel. A into greatest integer function of h plus b into greatest integer function of 2 plus h. Now this is 1, h is 0. Now what is greatest integer function of h? So a plus h is simply a. So 0 plus h is simply 0. So there will be 0. And then plus, now this is b. Now greatest integer function of a plus h, 2 plus h is simply 2. So this is 2. So left hand limit is 1 minus a plus b, and right hand limit is 1 plus 2 into b. So if the limit exists, then I can write left hand limit should be equals to its right hand limit. So left hand limit is 1 minus a plus b, and this is 1 plus 2b. So if I'll cancel 1 with 1, so I can simply write a plus b equals to 0. So answering this question is, so what are the possible values of a and b? So a and b can take any real values provided a plus b is equal to 0. So that is the answer to this question. While we are discussing limits and greatest integer functions, so I'll as well take up this question, which is limit x tends to 0. Greatest integer function, so this box in this example represents greatest integer function. 100x upon sine x plus 99 sine x upon x. So I need to find the value of this limit. So I know that limit sine x upon x is 1. So I cannot take this limit inside, because I know that if I have this limit, which is limit x tends to a f of gx, then I can take this limit inside of this function only when this function f is continuous at GA. If the function fx is continuous at GA, then I can take this limit inside. Otherwise, in that case, these two expressions, they won't be equal. So when I look at this, if I take this limit inside, I'll get x upon sine x is 1, which is 100. Now at integral points, greatest integer function of x, they are discontinuous. So I cannot take this limit inside the greatest integer function. So what do we do in this case? So in this case, we know that, suppose I take a small positive real number. So using calculus inequality, I know that sine x is always less than x. So here I can write sine x upon x is always less than 1. So if I multiply it with 99, so 99 sine x upon x is less than 99. If I take greatest integer function, then because it is less than 99, so this value will be simply 98. Now what about the other expression? Now when sine x is less than x, then x upon sine x is greater than 1. So if I'll multiply it with 100, so 100x upon sine x is greater than 100. So now if I'll take greatest integer function again, so there'll be some number which is greater than 100. So this is simply 100. So if I add them both up, so answer to this question will be 98 plus 100, there'll be 198. Now in this question, one thing that I'll also need to note is, we know that limit x tends to 0, sine x upon x is simply 1. So sine x upon x is less than 1 when x tends to 0. Sine x upon x is not 1, but it is nearly 1. That is, it is just less than 1. So in this case, I have assumed that this value, so in this case, I know that this value will be greater than 98. In the same way, this value will be less than 101. And that is the reason I could write greatest integer function of this function as 98 and greater function of this function as 100. So that is how we have got this answer as 198. So let us take another question in limits, which is limit theta tends to 0, greatest integer function of n sin theta upon theta plus n tan theta upon theta, where n is a positive integer and this box represents greatest integer function. Now what I know is theta is a very small number. So from calculus inequality, I can say sine theta is less than theta is less than tan theta. So if I'll multiply it by theta, I can write it as sine theta upon theta is less than 1 and it is less than tan theta upon theta. Now I need n sin theta and n tan theta. So I'll multiply it by n. So this is n sin theta upon theta is less than n and it is less than n tan theta upon theta. I cannot take this limit inside this greatest integer function, because in that case it will be sin theta upon theta is 1. So it is n, which is an integer. So at integral points, greatest integer function is discontinuous. So I cannot take this limit inside either of these two expressions. Now looking at this first expression, I know sin theta upon theta is 1. So this value n sin theta upon theta is nearly n, but exactly not equal to n, little less than n. So in that case, greatest integer function of n sin theta upon theta, it will be n minus 1. In the same way, this n tan theta upon theta, so tan theta upon theta is nearly 1, but still little greater than 1. So n tan theta upon theta is little greater than n. So that is greatest integer function of n tan theta upon theta is equal to simply n. So if I'll put this value, in this limit, I'll get this result as, so this is n minus 1 plus n, so this is 2n minus 1. So answer to this limit is simply 2n minus 1. Limit x tends to 0, greatest linear function of 2 sin x plus 10x upon x, where this box represents greatest linear function. Now in this case also, sin x upon x is 1, 10x upon x is 1, which is 3. Now 3 is an integral point, so at integral point, greatest linear function is discontinuous, so I cannot take this limit inside. So I need to solve it separately. So what I'll do is I'll write it as 2 sin x plus 10x upon x. So I'll use expansion formula. So I'll write the expansion formula for sin x. So it'll be 2x minus x cube upon factorial 3, x to the power 5 upon factorial 5, and then plus, and 10x is x plus x cube upon 3 plus 2 by 15 x to the power 5 whole divided by x. Now here 2x plus x will be simply 3x, and then 2x cube by factorial 3 it will be x cube by 3 and plus x cube by 3, so we'll cancel, and then I'll get this as 2 by factorial 5 plus 2 by 15 x to the power 5 whole divided by x. So if I divide by x, I'll write 3 plus 2 upon factorial 5 plus 2 by 15 x to the power 4. Now this x to the power 4 and this expression, it is a positive coefficient with a positive power, so this value will be positive, and all the remaining power, as the power increases, the value of this x to the power n, it decreases. So this expression will be 3 point something, some positive value. So in that case, if I take its greatest linear function, so greatest linear function of 2 sin x plus 10x upon x, when x tends to 0, it will be simply 3. So answer to this question is simply. Now let us take another question, which is limit x tends to pi by 4, 1 plus greatest linear function of x to the power 1 upon log 10x. Now look at this question closely. Now when I say this is pi by 4, so greatest linear function of pi by 4 is, so pi is 3.14 divided by 4, so there will be less than 1. So this value will be 0. So when I look at this expression, so this is 1, and then log 10 pi by 4, 10 pi by 4 is 1, and log 1 it will be simply 0, and it will be infinite. So there will be infinite or minus infinite, so that is 1 to the power infinite form. Now how do I solve this one? So what I'll say is answer to this question is simply 1 without having to solve anything. Now because I have greatest linear function of x here, then I cannot write it as 1 to the power infinite form. The problem being that when x tends to pi by 4, this greatest linear function of x, it doesn't tend to 0. Greatest linear function doesn't take a limiting value. It always takes an exact value. So greatest linear function of x, it cannot tend to 0. It can only be 0. If you look at the graph of greatest linear function of x, so it is 0, and then 1, and then minus 1. So it cannot approach 0. So from minus 1, it will directly go to 0, and from 0, it will directly go to 1. So greatest linear function of x, it cannot take a limiting value. Greatest linear function of x will always take an exact value. So if I am solving any limit having greatest linear function, so now in this case, when x tends to pi by 4, so this greatest linear function of x, it isn't tends to 0, it is exactly 0, then I am left with this 1 to the power 1 upon log 10x, and 1 to the power anything is 1. It is 1 to the power infinite form when it is tends to 1 to the power tends to infinite. So this limit is not 1 to the power infinite limit form. The answer to this limit simply is 1. So the question is limit x tends to 0, greatest linear function of 1 minus e to the power x sin x upon mod x. So what I'll do is, I see this mod sin x upon x is 1, 1 minus e to the power 0 is 0, so which is an integer. Again, I cannot take this limit inside this greatest linear function. So what I'll do is I'll write left hand limit. Now left hand limit will be limit x tends to 0 negative, greatest linear function of 1 minus e to the power x sin x upon mod x. So what I'll do is I'll let x equals 0 minus h. So it will be limit h tends to 0 positive 1 minus e to the power h sine minus h and mod of minus h. So I'll write it as limit h tends to 0 positive, greatest linear function of 1 minus e to the power minus h and minus sine h upon h. Now I cannot take this limit inside, so what I'll do is I'll write them separately. So 1 minus e to the power minus h and then minus sine h upon h. Now e to the power 0 is 1. And if I take any number, and that is the graph of e to the power minus x. So if I take any small positive number h, so in that case, this value, it will be less than 1. So that is e to the power minus h will actually be less than 1. So if I take it on the right hand side, I can say 1 minus e to the power minus h is greater than 0, but it will be less than 1. And I also know that sine h upon h, sine h is less than h, which is sine h upon h is less than 1. So if I'll multiply with the minus sign, I can write it as minus sine h upon h is greater than minus 1, but it will still be less than 0. So I've got two expressions. One of the expression lies between 0 and 1 and the other expression lies between 0 and minus 1. So if I'll multiply two numbers, one of them is positive, other one is negative. So if I'll multiply them, then the result will be negative. Now first value will lie between 0 and 1. Next value lies between minus 1 and 0. So if I'll multiply them, then what will happen is 1 minus e to the power minus h into minus sine h upon h. So their value will lie between minus 1 and 0. And when the expression lies between n and n plus 1, its greatest integer function will be simply n. So in this case, the value of left hand limit is simply minus 1. Now I'll solve the right hand limit. If I'll solve right hand limit, I can write it as limit x tends to 0 positive 1 minus e to the power x sine x upon mod x. Now in this case, I'll let x equals 0 plus h. So it will be simply limit h tends to 0 positive 1 minus e to the power h sine h upon mod h. Now h is a positive number, so I'll write it as limit h tends to 0 positive 1 minus e to the power h sine h upon h. Now 1 minus e to the power h, so that is the graph of e to the power h. So e to the power 0 is 1. If I take a small positive number, then in that case I'll get this value as e to the power h, so which is greater than 1. So in this case, e to the power h is actually greater than 1. So if I take e to the power h on the right hand side, I can write 1 minus e to the power h is less than 0, but it will be greater than minus 1. And also I know that sine h upon h, this is less than 1, but greater than 0. So if I multiply them again one of the number is positive, lies between 0 and 1. Another number lies between minus 1 and 0. If I multiply them, result will be negative, and the resulting expression will lie between minus 1 and 0. Now when the number lies between n and n plus 1, its greatest linear function is n. So in this case also, the value of limit is minus 1. So when left hand limit and right limit exist and they are equal, the value of this limit is simply minus 1. So answer to this question is minus 1. So now we'll discuss inequalities of greatest integer function. Suppose I have an integer a and I have four cases. Case 1, when greatest integer function of x is greater than or equal to a. Second case, when greatest function of x is greater than a. Third case, when greatest integer function of x is less than or equal to a. And the fourth case, when greatest integer function of x is less than a. Now in each of the case, a is an integer. Now I'll take up the first case. When I say greatest integer function of x is greater than or equal to a, what I know is greatest integer function of x can only take integral values. So the kind of integral values it can take is x can be either a or a plus 1, a plus 2. So if greatest integer function of x is equal to a, then x lies between a and a plus 1. Its value is a plus 1 when it lies between a plus 1 and a plus 2. Again, when it lies between a plus 2 and a plus 3. So if I look at this equation, then I know that this x should be greater than or equal to a. So if greatest integer function of x is greater than or equal to a, then the simple result will be x should be greater than or equal to a. Say for example, if I say, so greatest integer function of x is greater than or equal to 2. So either greatest integer function of x is 2, or greater function of x is 3, or greatest integer function of x is 4. So it is 2 when x lies between 2 and 3. It is 3 when x lies between 3 and 4. It will go on. So it will start from 2 and will go all the way up to infinite. So answer to this question will be simply x should be greater than or equal to 2. So either we can do it using logic, or we can simply remember the result. So if greatest integer function of x is greater than or equal to a, then the result is x should be greater than or equal to a. Now what if greatest integer function of x is greater than a? Now in this case, when greatest integer function of x is greater than a, then the minimum value of greatest integer function of x will be a plus 1, then a plus 2. So now this value is a plus 1 when x lies between a plus 1 and a plus 2. When it lies between, it will be a plus 2 when it will lie between a plus 2 and a plus 3. So that is, its value should always be greater than a plus 1. So in this case, answer will be x should be greater than or equal to a plus 1. So that's your direct result. Suppose I say greatest integer function of x is greater than 2. So that is, greatest integer function of x can take the value 3, 4, 5. So it will be 3 when it lies between 3 and 4. 4 when between 4 and 5 will go on. So in this case, the value of x should be greater than or equal to 3. So either use logic, or we can use the result directly. If x is greater than a, then if greatest integer function of x is greater than a, then x is greater than or equal to a plus 1. Now what about the third case? Now in the third case, when I say greatest integer function of x is less than or equal to a, then greatest integer function of x will take all the values. So a minus 1 and then a. It will take the value a minus 1 when it lies between a minus 1, a minus 2, a minus 1. It will take the value a minus 1 when it lies between a minus 1 and a. And it will take the value a when it lies between a and a plus 1. So from here, the result I'll get is the value of x should be less than a plus 1. Now say for example, suppose I say greatest integer function of x is less than or equal to 2. So here I know greatest integer function can take the values 0, 1 and then 2. So it'll take the value 0 when it lies between 0 and 1. It'll take the value 1 when it lies between 1 and 2. It'll take the value 2 when it lies between 2 and 3. So from here I can say the value of x should be less than 3. So when greatest integer function of x is less than or equal to a, then simply x is less than a plus 1. So in this case, x is simply less than 3. And the fourth case, that is when greatest integer function of x is less than a. So in that case, greatest integer function can take the values. There will be a minus 2 and then a minus 1. Now it cannot take the value a. So it will be a minus 2 when it lies between a minus 2 and a minus 1. It will be a minus 1 when it lies between a minus 1 and a. So from here I can simply say x is simply less than a. So if I say greatest integer function of x is less than 2, then the value of greater function can be 0, 1. It cannot take the value 2. 0 when it lies between 0 and 1. It will be 1 when it will lie between 1 and 2. So from here, answer I'll get is value of x should be less than 2. So when greatest integer function of x is greater than or equal to a, answer is x is greater than or equal to a. When greatest integer function of x is greater than a, answer is x is greater than or equal to a plus 1. Third one is when greatest function of x is less than or equal to a, then the answer is greatest integer function of x is less than a plus 1. And for the fourth one, when greatest integer function of x is less than a, then it is simply x is less than a. Now let us give an example. So the question is, there is a function fx defined as 1 upon under root of greatest integer function of x square minus greater function of x minus 6, and we need to find domain of this function. Now because we have a square root in the denominator, the condition here will be greater function of x square minus greater function of x minus 6, it should be greater than 0. So what I'll do is I'll let this greater function of x as y. So I can write it as y square minus y minus 6 should be greater than 0. So y plus 2 y minus 3 is greater than 0. So I'll put it on a number line. So this is minus 2. This is 3. So this is plus, minus and plus. So I need greater than 0, which is plus. So I'll get the result as either the value of y is less than minus 2 or the value of y is greater than 3. So if I'll put the value of y, I can write either greatest linear function of x is less than minus 2 or greatest linear function of x is greater than 3. So either I can use the formula directly. So when greatest linear function of x is less than a, then it is simply x is less than a. So from here I'll directly write x is less than minus 2 or now when greatest linear function of x is greater than a, then x is greater than or equal to a plus 1. So from here I'll write x is greater than or equal to 4. So here answer will be x belongs to, so from minus infinite to minus 2 union from 4 to infinite. So either we can solve the question directly using the formulas or I can solve it in a different way. So if I say greatest linear function of x is less than minus 2, what I know is greatest linear function will take all the values minus 4, minus 3. It'll be minus 5 when it will lie between minus 5 and minus 4. It'll be minus 4 when it will lie between minus 4 and minus 3. It'll be minus 3 when it will lie between minus 3 and minus 2. So from here I can say the value of x should be less than minus 2. Now for the second part, if I say greatest linear function of x is greater than 3, then I know it will take the value 4, 5. So it is 4 when it lies between 4 and 5. 5 when it lies between 5 and 6. In this case, the value of x should be greater than or equal to 4. So answer I'll get is either the value of x is less than minus 2 or the value of x is greater than or equal to 4. Now let us take another question, which is greater function of x square minus greatest linear function of x minus 2 upon greatest linear function of x minus 3 pi is less than or equal to 0. Now what I'll do is I can write it as let greater function of x is y. So this is y square minus y minus 2 upon y minus 3 pi is less than or equal to 0. So this is y minus 2 y plus 1 y minus 3 pi is less than or equal to 0. So this is minus 1 and then 2 and then 3 pi, and this is what? This rightmost is plus, minus, plus and minus. So I can write it as, so I need what? Less than 0. Less than 0 is negative. Now because 3 pi lies in the denominator, I'll not include it and I'll include minus 1 and 2. So I'll simply write y is less than or equal to minus 2 or the value of y lies between 2 and 3 pi. So I can write greatest linear function of x is less than or equal to minus 1 or greatest linear function of x is less than 3 pi. Now greater function of x less than a, it simply means x is less than a plus 1. So from here I can say x is less than 0. And from here what I know is the value of greatest linear function of x will lie between 2 and 3 pi, and 3 pi is 9 point something. Now it cannot take all the values, it can only take integral values. So this is 9 point something. So from here the result I'll get is the value of greatest linear function of x should lie between 2 and then 9. So now when greatest linear function of x is greater than or equal to a, so it is simply x is greater than or equal to a. So I'll write x is greater than or equal to 2, and when greatest linear function of x is less than a, less than or equal to a, it is x is less than a plus 1. So this is less than 10. So answer to this question simply will be either the value of x is less than 0 or the value of x will lie between 2 and 10. So which is x belongs to from minus infinite to 0 union from 2 to not included 10. So that is the answer to this inequality. So the question is find the left hand derivative and right hand derivative of the function fx equals greatest integer function of x into sine pi x when x is k and k is an integer, and this box represents greatest integer function. Now, when I look at this function, this is greatest integer function which is discontinuous at any point k, but then at any integral point, this is sine k pi, and sine k pi is 0. So 0 into any discontinuous function will make that function continuous. So without even solving, I can say that this function fx is continuous at x equals to k. Now I need to find its left-hand derivative and its right-hand derivative. So left-hand derivative at k, so f dash k negative, it can be written as limit h tends to 0 f k minus h minus fk upon minus h. So I can write it as limit h tends to 0, and this is greatest middle function of k minus h into sine pi into k minus h. Now fk, which is sine k pi is 0 because k is an integer, upon simply minus h. Now what I know is greatest middle function of a minus h is a minus 1. So I can write it as limit h tends to 0, and this is k minus 1. And what I also know is, so this is sine k pi minus pi h upon minus h. Now what we know is sine n pi minus theta is minus 1 to the power n minus 1 into sine theta. So I can write it as this is limit h tends to 0, and this is k minus 1. Now sine k pi is minus 1 to the power k minus 1 into sine pi h, and this is minus 1 and then h. So what I'll do is I'll multiply pi with pi. Now because it is h tends to 0, sine x upon x will be 1. Now minus 1 to the power k upon minus 1, so it will be minus 1 square, minus 1 to the power k into k minus 1 into pi. Now its right hand derivative will be f dash k positive, which is limit h tends to 0 f k plus h minus fk upon h. So I'll write it as limit h tends to 0 f k plus h is simply greatest integer function of k plus h sine pi k plus h minus fk is simply 0 upon h. Now greater function of k plus h is simply k. So this is limit h tends to 0, and this is k, and this is sine, and it is k pi plus pi h upon h. Now what is sine n pi plus theta? Sine n pi plus theta is minus 1 to the power n into sine theta. So when n is odd, it is minus. When n is even, it is plus. So I can write it as limit h tends to 0, this is k, and this is minus 1 to the power k into sine pi h upon h. Again I'll multiply and divide with pi. So again h tends to 0, sine h upon h will be 1. So I'll get this answer as minus 1 to the power k into k pi. So left hand derivative is minus 1 to the power k minus 1 pi, and right hand derivative is minus 1 to the power k into k pi. So this is how we can find left hand derivative and right hand derivative. So the question is, I need to find the value of this integral, which is from 1 to a, greatest integer function of x into f dash x dx when a is greater than 1. So what I'll do is I'll write it as from 1 to a, greatest integer function of x into f dash x dx. Now what I know is between any two successive integers, greatest integer function is nothing but a constant function. So I'll split it as from 1 to 2, greater function of x into f dash x dx. From 2 to 3, greater function of x into f dash x dx. I'll go on, and then from greatest function of a minus 1 to greatest function of a, then greatest function of x into f dash x dx, and finally it will be from greatest integer function of a to a, and there will be greater function of x into f dash x dx. So what I've done is I've split it as 1 to 2, 2 to 3, and finally it'll be up to a, but a may not be an integer, right? So before that, the integral value will be greatest linear function of a. So I'll split it as greatest linear function of a minus 1 to greatest function of a, and then greatest linear function of a to simply a. Now between 1 and 2, this value is simply 1. Between 2 and 3, it'll be 2. Between greatest function of a minus 1 and a, it'll be simply greatest linear function of a minus 1. And between greatest linear function of a and a, it'll be simply greatest linear function of a. So I can write it as from 1 to 2, 1 into f dash x dx. Between 2 and 3, it'll be 2 into f dash x dx. Here will be greatest function of a minus 1 to a. It'll be greatest function of a minus 1 into f dash x dx, and then greatest function of a to a, and there'll be greatest function of a into f dash x into dx. So now I'll integrate this function. Integral of f dash x is simply fx. So there'll be 1 into f2 minus f1. There'll be 2 into f3 minus f2. Here will be greatest linear function of a minus 1 into f greatest function of a minus f greatest function of a minus 1. And then will be greatest linear function of a into f a minus f greatest integer function of a. Now if I look at this function, then what I'll get is, I'll get this expression which is greatest integer function of a into fa, and here I'll get this as minus f1. Now what about f2? It is 1 f2 and then minus 2 f2. So there'll be minus f2. Here will be 2 f3, and the next one will be minus 3 f3. So it'll be minus f3, and it'll continue, and it will continue up to this last one. So this is a into minus fa, and there'll be a minus 1 into fa. So there will again be minus f into greatest linear function of a. So if I write, I can write it as, so this is greatest linear function of a into fa, and then minus, it'll be f1 plus f2, and it will continue up to f greatest linear function of a. So answer to this question simply will be a f a and up to greatest linear function of a. So greater function of a, and then a, and then will be greatest linear function of a. So B is the answer to this question.
If you like the video, consider subscribing and sharing it with someone you know who might benefit from it. Also, the best way to navigate any topic is through a playlist. Simply go to the channel page, click playlist, and select the topic you wish to study.